fossil is?
My grandmother?
Oh, not yet.
Watch me whip, watch me nay. Can you do it? Now I need, watch me.
Not yet. A fossil is an impression of a prehistorical animal and plant. The animals or plant remains are compressed into layers of sediments along with other dissolved minerals. Fossils take at least 10,000 years to form through pressure, erosion, chemical reactions, and weathering.
Is that it? That seems pretty simple. I don't understand the importance in the rock cycle.
Well, you see, the rock cycle is a combination of external and internal forces which give off energy and allow the rocks to change and move along the cycle through erosion, weathering, transportation, magma eruptions, and natural forces and disasters. Fossils are formed through the whole rock cycle process because they use some of the same forces. The animal remains can be covered by sediments and be transported by water and wind and mixed with the other minerals and clays. After erosion weathering, which is a natural effect on all matter of the earth, the rock begins to form around the remains, creating an imprint and silhouette. The pressure of the other sediments being layered on top allow the remains to mold into its surroundings and to the smaller pieces of mineral to form into between the spaces of the bones.
Can we see what fossilization looks like?
Well, we can make an artificial fossil in less than 10 minutes rather than waiting 10,000 years for the next one to be discovered. Before we start this experiment, I would like you to state your hypothesis of what you think will occur.
I predict the fossil will have an imprint on one side. It will be hard as rock. I also think we will have an almost perfect reflection of the seashell in our clay mold. What materials are we going to use?
We're going to do the fossil of the seashell, so we're going to be using a seashell, plasticine, some plaster of Paris, and some disposable utensils and water. Step 1. Take your seashell and cover it with plasticine. The plasticine acts as the layers of sediments that are molding around the remains and filling the cracks and details of the remains every day. The clay must be firmly pushed in with great force to grasp every tiny detail to make it look as realistic as possible. This is a representation of transportation in the rock cycle, when new sediments and materials are being moved by water or wind onto the spot of the animal's bones. The force pushing it down is yourself in this case, but in the earth it is the forces of the atmosphere and the weight of the layers being laid above. To make a fossil, you'll need the object you want to make it off of, so the remains. So we're going to do a seashell. Then you're going to need some plasticine clay, which is going to be used to form it and make the silhouette of it. Then you're going to need some plastic containers and spoons, something that you can just throw out after or you don't care about if you get the clay stuck in it. Lastly, you're going to need some plaster of Paris, which will be mixed with water to create a creamy substance, which will then fill the clay and create the fossil itself. So to start off, you're going to cut a piece of clay and get a good piece and break it up if you have to, and just massage it in your hands for about 5 minutes to make sure that it's nice and smooth and then easy to put onto the seashell. Now with the clay that you have made smooth, you're going to push it onto the seashell to get its shape. This would be the same action of all the external forces that are pushing the sediments into the remains and all of their details, along with the sediments and minerals that are being pushed into it, such as other pieces of fossils, gravel, minerals, and anything that came from the ocean due to transportation. Other than transportation, this method can be known as lithification since that is what is occurring to the sediments. Lithification, the process in which sediments are compacted under pressure, expel connate fluids, and gradually become a solid rock. It is the process of porosity destruction through compaction and cementation. It is also known as the process that turns loose, unconsolidated sediment into solid sedimentary rock.
For you to know that the top layers push down on the ones below. Cementation, yeah, glues it all together. Sediment that's stuck together is just so much better. And if you're lucky, you might discover some fossils. They even older than the food be at McDonald's. Clap your hands, we have sedimentary rock.
Step 2 is to remove the mold from the seashell and fill it with the plaster of Paris that you will be making. The plaster of Paris acts as all the sediments that were already below the remains, where the remains had first left their imprint because they were forced into it. Once this dries, it'll make a larger chunk of rock at the back, making it look more realistic as if the fossil was just chipped out of a grand piece of rock. This material can represent how the water and rain and minerals mix and make up the rock around the fossil and get into every little detail and curvature of the fossil. The plaster may have imperfections when doing it and air bubbles when it dries, which can make it more visually accurate, but not always more appealing. For step 2, we're going to be using the plaster of Paris. So I already have mine in my container, and it's just a powder, like that. And slowly we're going to add water and mix it. So just add a bit, and then if it's too hard, then just keep adding more to make sure it becomes kind of like a liquid and not too. This is what the end result looks like. It's just kind of like yogurt, a little bit thicker though. And I'm just gonna use it. Make sure you don't do this too soon, too early, because it will dry into the container and then you won't be able to use it for this. So for this, you're just going to peel it off. You're going to now get your mold, and you have to be really careful because you don't rip it or anything. So just peel it along the sides, and then after you can fix its form a bit. So you're just going to peel it gently back, just like so. And as you can see, it has all the ridges, just like the clam did. Now it's going to be hard to pour something on a flat surface, so I'm just going to pinch it at the bottom and form it up a bit. Now I'm going to take the plastic of Paris, and I'm going to scoop it up just a little bit first, and put it in, just like so, and then smooth it into it. Now, because this is really thick and really big and we have to put in a lot of the plaster of Paris, it's going to take about 25 to 45 minutes, depending on how large. This one should take about 30 minutes to completely dry, and then we'll move on to step 4 and the final step. For the final step, you're going to wait till this is dry, so not too dry because you want to be able to still take off the clay, but not that it melts in your hands. So slowly you're just going to go around the corners and remove the clay shell that we made. And a little bit of the plaster of Paris might come off too, but that's okay because it'll just give it more of a ridgy look. So you just want to slowly do it. And as you can see, it still has its form. And now, so does your fossil. Just like that. And that's how you make an artificial fossil. Now, can you share with us why you think fossils are important?
I think fossils are important because it allows us to see back in time and how the Earth was 10,000 years ago.
Now, can you tell me which direction the pressure came from to squash the fossil?
The pressure came from your hand pushing the plastic down onto the outer side of the shell. This is an external force coming from above.
That is correct. The forces that make fossils are external forces, such as the sun and forces in the atmosphere. Wind is also an important factor of fossilization. The forces that make fossils are the same as the ones in the rock cycle. That is how the rock cycle and fossil cycle are closely related and work together, as you will see in the next explanation. Now we will go into further detail on the rock cycle's relation to fossils. Whoops, that's the wrong rock cycle. Now, to make sure you understand exactly how a fossil correlates with the rock cycle, I will give you a full explanation of something becoming a fossil. So, to start, we will use the living dinosaur, and we will think about when a volcano erupts all of its lava. So in this case, it will be extrusive, so it will become an extrusive igneous rock, and when it pours over the dinosaur, obviously killing it. And the heat eating away at its flesh over the times, and then the rocks and the lava filling into the bones. After a while, the weathering will break up sediments around it and break up its own sediments and continue moving this piece of bone or the remains throughout the rock cycle through transportation and deposition. After transportation, a lot of sediments will be put on top through lithification due to wind and water movement. After this, it'll obviously go through lithification and become the sedimentary rock. Once it becomes a sedimentary rock, it can go through metamorphism and restart the whole process if this fossil has not been found, or even made it going back into the ground and restarting its whole process, losing this piece of history. So that was an example of a dinosaur from life to death becoming a fossil. Although that is not what we spoke about in this video, that'll give you a good visual and a very bleak explanation of a fossil going through the rock cycle. How can a fossil in real life get squashed or twisted? Sedimentary fossils can get squashed or twisted when going through metamorphism, which is the changing of a rock. Metamorphism is caused by the plates moving. This is part of the plate tectonic theory, stating that there are about 20 plates that are constantly moving due to convection currents. Metamorphism gets its heat from the heat of the Earth through convection currents that's under Earth's core. The movement of the plates and the heat from the convection currents causes these fossils to be squeezed and deform their shape overall. This is how a fossil can be squashed or twisted, through heat and pressure.